Biot Savart law. Biot Savart law look very similar to the Coulomb's law. In Coulomb's law, what happened? Force directly depend upon the charge, inversely depend upon the distance. And okay, it's almost same. If you see in this situation, magnetic field will depend upon the current, because remember, magnetic field always exists because of current. Example, if magnetic like current is moving from left to right, your compass will show deflection. If it is right to left, ulta direction of current, compass will show deflection in the opposite direction. If you uh, keep compass away, it means if you in reduce the distance, then there will be more deflection. If you increase the distance of the compass, then deflection will be less. इसने बेहतर दो. Guys, give me a minute. So, hello, hello.
Yes, sir.
So, Biot Savart law. Uh, if I explain you Biot Savart law, because this is really important, I'll explain you separately also. Very popular uh, formula, and remember, based on this formula, you have everything in this chapter. If I have to say one basic formula you need in the whole chapter is Biot Savart law. 90% of this chapter question can be done by using only this law and its modification. Example, magnetic field is always because of the current, not static charge. As of now, we were talking about electrostatic in electrostatic unit. Here we are talking about electrodynamic when electron is moving. So if you consider electrodynamic, it means electron is moving, and because of this movement, there is current, and due to this current, now you have magnetic field. Example, if you have this wire, and in this wire current is moving in one particular direction, example upward direction. So what will happen around this current? You will see one region where your compass can show deflection, region around the current carrying a wire, in which compass will show some deflection. This region is known as magnetic field. This region is known as magnetic field. Electric field is the region around the rest stars. Magnetic field is the region around the moving wire. Okay. Second, if you take because of this small section, example this part is DL. Here at r distance from this, you want to calculate your magnetic field. So can we say this what will be the amount of small magnetic field? It will depend upon the current as well as the DL section you are taking. Correct? So I cross DL. It depend upon the amount of current. More current, more magnetic field. More length, more magnetic field. Okay. Second, it depend upon the angle also. At what angle you are considering this? Angle matter a lot. So we can say ki angle also matters. So I DL sin theta. Even cross means you have to consider this. Correct. Third, it depend upon the distance R also. If your compass is nearby, so deflection will be more. If compass is far away, deflection will be less. So it depends upon the r square. Okay. And if you remove this constant, it depends upon the nature of the medium also. That's why your dB will be equal to nu naught upon 4 pi, which is the constant, ideal current vector, r square distance, and angle between them sine theta. Trust me, if you have best understanding of this, you can do most of the thing. Example, most of the thing are constant. What will change dl value? You have to do integration. So when you will calculate magnetic field, which is the integration of dB, then nu naught upon 4 pi will be constant, I will be constant, r square will be constant. You will have at a particular angle from where you are calculating. So sine theta will be constant, but it can change also depend upon the situation. What will you do? You will do integration of dl. Let me give the simplest example of the same thing to give you the easiest way how we can derive other thing. Example, you have a circle of radius r and you have a current wire entering into it. You have current wire entering into it. If current is entering into it like this, what will happen? Your magnetic field will move in the current is moving inside. So what will happen? Magnetic field will be present in the around region. You take a pen inside your notebook. So region around your pen will be magnetic field region. So in this case, you want to calculate magnetic field. So how to calculate magnetic field for this circular ring? So nu naught upon 4 pi is constant. You have I current. Sine theta. In this case, angle will be 90 degree. Theta will be 90 degree, perpendicular to each other. Most of time, if nothing is given, you will consider angle always 90 degree because here it will be perpendicular. Okay, compared to this road or pen going inside the ring, so it is perpendicular. So sine 90. This radius is r square. Now you have to integrate dl. So example, if you take small section dl and integrate this, what will be the value? Chandana, nu naught upon 4 pi I r square. Will it be 2 pi r circumference?
Yes, sir.
R will be cancelled, 1 r, and pi will be cancelled. This will be 2. So B is equal to nu naught I by 2r. Trust me, 99% of people try to remember this formula. But we know if you are able to just do integration of dl, your answer is already done. You don't need to remember anything. And Biot Savart is very logical. More current, more magnetic field. More distance, less magnetic field will be felt. Angle matter. In case of electric field, angle does not matter. Done. Understood. So DL integration, you will get answer. So we are not bothered about the what is the circular ring magnetic field. We know that we have to do integration of DL and we'll get answer. I will not remember any formula from that. Tell me, guys, were you doing this mistake and you were memorizing each and every formula of magnetic field? Sarah,
No, sir.
Jordan,
No, sir.
like what is the meaning of your no? Like you don't have doubt, or like you were not doing
No,
like
I don't have any doubts. I understood.
no. But were you doing like this? Ki you were memorizing every formula for the circular ring, for infinite road, for many other stuff.
Not exactly, sir, because I remembered it from what electrostatics. So same implementation.
Yeah, comparison, that is a really good method. You can compare. But in example, electric field, you see ki there again derivation, but you have long derivation. In this chapter, you will have very short derivation, like just integration of DL, and your answer is ready.
Yes, sir.
But in
That way, no.
example, if you are doing electric field for the dipole, you know you have to do lengthy calculation to get the final answer.
Yes, sir.
Chandana?
If you take it that way, yes.
Yes. Chandana,
Yes, sir. Sometimes.
like for your boards, you used to do proper derivation and you used to remember everything.
Yes, sir.
Okay. Barinder,
No, sir.
Pratigya,
No, sir.
hmm. Anvita, any doubt?
No, sir.
Huh. So new note is for free space or vacuum. Free space or vacuum. And you know this is the standard value in case of free space or vacuum. And this value will change free space or vacuum. Okay. It means if you take a particular medium, then it will change. Same thing like if when you were taking permittivity, epsilon naught, it was for free space or vacuum. For a given medium, it was epsilon. Same. For free space or vacuum, it will be nu naught, but for a given medium, it will be nu. And value is this. 4 pi into 10 is 1 minus 7. Uh, Pratigya, what will be the unit of nu in this case?
Meter per second.
Hmm?
I don't know.
Unit of magnetic field is Tesla. You know this. Then if you take
Yes, sir.
DL
Weber
up
per
and
meter.
Weber per meter. Okay. So you can take this in the Weber form. How? Because magnetic flux you will calculate is B dot dA like this. How we did integration in case of electric flux goes along, right? So magnetic field is present in the form of Tesla unit and dA area r square. So what will be the unit of magnetic flux? Weber. So if r square go into the multiply, it will be Weber. Divide by current is ampere and this is length. So it will be either Tesla meter per ampere or it will be Weber per ampere per meter. Weber uh, per ampere per meter. Understood, guys, or should I explain this? What I did? I think I have to. So, what happened using the same formula? I will write again. We know magnetic field is nu naught upon 4 pi I dl sin theta upon r square. You want to calculate new value. So, it will be like b into 4 pi r square divided by I dl sin theta. Unit of magnetic field is Tesla. So Tesla, this is almost like area, A area, Tesla meter square, divide by current ampere, and DL meter. So 1 meter cancel. This will be Tesla meter per ampere. Or second thing is when you say this IDL sine theta, so this magnetic field into area is known as Weber divided by current ampere and DL will be in meter. So it will be Weber per ampere per meter. Any doubt, guys? So both are correct. Understood? Yes or no?
Yes, sir.
Hmm. If you take a straight wire, in case of straight wire, and you calculate what is the total magnetic field, nu naught upon 4 pi is same like Biot Savart law. I remain same. It's like if you take DL in the form of R, so one R will be in numerator and R square will be in denominator. So what will be the remaining? Only R. And if different angle are present here, alpha and beta, so it can be sine alpha and sine beta total value. Make sense? Ask your doubt. Any doubt, guys? Nu naught upon 4 pi I. Instead of DL, it is like you are taking the dimension of R, meter, na? Length. So R will be cancelled. In denominator, you have only single R. And if different angle, you have sine alpha plus sine beta. Okay. In case of road, imagine if you are taking infinite road, what will happen? Both angle will be 90 degree. You already did this. If both angle is 90 degrees, sin alpha value will be 1, sin 90 value 1, sin beta 90 will be 1, 1 plus 1, 2. That's why you have 2 here. Tell me yes or no.
सर एक बार फिर बता दो.
The rule for the infinite road is, in this case, your angle will become 90 degree. Alpha and beta both. These both alpha and beta will become 90 degree. Okay. Sin alpha will be equal to sin 90 is equal to 1. Same way, sin beta in case of infinite road only, it will be equal to sin 90, it will be equal to 1. So 1 plus 1 will be 2, and instead of sin alpha plus beta, what do you have? 2. Make sense? Barinder, any doubt?
Yes, sir. No, sir.
Only for infinite road. Only because that is the rule for the infinite road key. You have to take angle 90 degree. Okay. If you take semi-infinite, I think we took in one of the situation. Ki infinite road, we took angle 90 degree, and in semi-infinite, one angle was 90, another angle was 0. You know, sine 0 will be 0. That's why you have only I, not 2I. Make sense, guys? Any doubt?
No, sir.
No, sir.
Hmm. Sometimes we have to calculate magnetic field at the center of different situation. At the center of different situation depend upon the side. How many side do you have? In that case, this is the formula. Nu naught upon nu naught and I, the n, and the number of side. Pi L, almost more or less same form, but here you will have tan theta in some form and sin theta in pi by n. Example, in case of rectangle, how many side do you have? 4. That's why n value will be 4. And tan theta you calculate like 10 pi by n, and n value is 4. So what is pi by 4, Sarah?
So one.
No, pi is 180. So answer is 1. This is correct. But pi by 4, it means it will be 1045, and
Yes.
1045 value is equal to 1.
So can you
Right?
explain it
So
again, sir?
see, if you just go through the formula, it will look difficult. Okay. But if you apply the formula, it will look easy. Example, in first rectangle, only this rectangle. How many sides do you have, Jordan? 4.
Four sides.
Huh. So apply the formula. You note I pi l is the common value. Now you have to consider what is the number of side. 4. Then you have one angle as 10 pi by n. Tell me what is the n value here?
Four.
4. What is pi by 4? 1045.
45. So tan 45
What
is
is
equal to 1.
1045 value?
1.
1. That's why we wrote it 1. Same you have sine pi by n. N value is 4. So it will be equal to sine 45, and it will be equal to 1 by root 2. Correct? That's why we wrote here 1 by root 2. Any doubt? And you will get answer.
No, sir,
Then
no doubt. No.
same here. Anvita, in this case, your formula is magnetic field if you want to calculate the center, nu naught Ni by pi L into 10 pi by n and sine pi by n. Give me 1 minute. हेलो. हाँ जा दे. ना 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 गया को नहीं, क्लास लेना ही था. कोई पक्का बेरा को नहीं भाई, गांव में तो जुगाड़ करने की कोशिश कर. हाँ. हम्म. जे तो जानता तो बता. ये करना. हाँ. तो तेरा सामान लाना कितना है? हाँ वो तो जरूरी है भाई बहुत. जितना टाइम तो लग गया भाई, तो रिक्वेस्ट ले आइए. अर्जे भाई न्यू है भाई. जे तो मतलब तेना ज्यादा काम हो जाए, औखा हो जाए, तो भाई फिर भाई बात है, पूरे तक करना पड़ेगा. सूंड की तो काम मत ले लेंगे यार. 50 100 रुपये ज्यादा लगेंगे, और कितना फर्क पड़ेगा? एक को 2 सूट चाहिए. कितना? 5 रुपया फर्क पड़ जाएगा एक पे. और एक को दो चलो, मैंने पूछना पूछ के मैं तेरे को बता दूँ थोड़ी सी मैं तो निकल गया आगे. अगली कढ़ाई. हाँ फिर ये तेरा कितने आना काम है? अगर आधा घंटा में तो ये नरवाना पहुंच लेगा, आधा घंटा में चल लेगा. ठीक है, तो घंटा में नरवाना पहुंच लेगा. और तेरा नरवाना कितनी देर का काम है तेरा खुद का? हाँ. हाँ. मैं नहीं, मैं तो नहीं जाकर अंदर, लेकिन तो एक को बार मैं ले आ सके, फिर तो तेरा पे भी बोझ पड़ जाएगा ज्यादा. बस एक तो सुनटा का करना था. चलो तो एक काम कर दूं, मैं एक गाड़ी बुक कर दूं. ठीक है. जिसमें तो भाभी ने लेकर जाओगा, नहीं तो वो भी काम हो जाएगा. और बुआ कर लगी जाएगी. अच्छा. फिर तेरी और बुआ की क्या वो कर दूं मैं. क्योंकि टुंटी का सामान बहुत ज्यादा तो होगा नहीं, जो ज्यादा तो होगा तो फिर तो बड़ी रेडी में दर्द दी है. जिम भी क्या मैं. और तुम और बुआ की क्या करा, गाड़ी बुक कर दिया तारी, तो नरवाना था सामान ले आइयो. और उसमें अंदर पे जावा गाड़ी में सही. और 1,000 रुपया में गाड़ी हो जाएगी, और तो की लागेगा. हम्म. हाँ. सुनते हैं ज्यादा को नहीं, है तो दो ही चेयर। ज्यादा को नहीं, दो ही चेयर है बस। क्योंकि मेरे के मैंने भी कौन जानता कि तुम जाडा में मोटरसाइकिल पर तंग रहो। जानते हैं, इसमें बात पीछे ही कोनी, बात ये है कि भाई जी काम करने लग जाना है तो थोड़ा सा शांति से बिक जाए तो कोई दिक्कत नहीं आवे। चलो तो न्यू कर ले, तो कर ले गाड़ी जी तेरा जाने पछाने का हो तो आप पीछे दे जाए। और बुआ भी अपना सारा सामान ले आवेगी तो ले आइए, उससे बता देते। ठीक है। यस गाइस। So, Anvita, this is the formula. Now tell me what will be your magnetic field in this situation. Anvita,
Not sure, sir.
n value is 6 and 6 side na hexagonal.
Yeah,
What will be the value?
we just have to multiply it, right?
Yes.
So 6 nu naught I by L.
Hmm. Next, what will
Then
be 10 pi by n value? What is n value here? 10 pi by n value
6.
6. What is pi by 6 meaning? What is the meaning of pi? 180-degree angle.
Yes, sir.
So pi
30.
by 6 will be, what is 30 value?
So 1.
Is it 1 by root
Yeah,
3?
1 by root 3. Yeah, my bad.
So 1 by root 3. Barinder, what is sin pi by n value?
So 30 degrees.
Sin 30 value?
1 by 2.
Done. Understood everyone? So when you just see formula, it look difficult. When you solve question through formula, it look easy. Next, Sarah, what will be magnetic field in this case?
The 3 mu naught I upon pi L.
Huh.
And,
What will be 10?
root 3 pi.
This is root 3
Yes, sir.
and sin pi by 3 value.
Root 3 by 2.
Done. All of you understood how we got these different values?
Yes.
Hmm. Then current direction. It is following right hand thumb rule, which say that if your current is outside, this dot means outward direction. Outward direction of the current. If current is outward direction, your magnetic field will use right hand thumb rule. So thumb toward you, toward your eyes, toward you, and then you finger show your magnetic field. So what is the direction of magnetic field? Clockwise or anti-clockwise, Jordan? Use your hand. See, your thumb, right hand thumb is coming toward you, and your finger are going,
Then it'll be
rotating
anti-clockwise if it's coming out of the
anti-clockwise.
plane. Yes, sir.
Yes. Then, Pratigya, if magnetic field is coming toward you, what will be the direction of current?
Inward.
Anti-clockwise magnetic field is toward you. Thumb is toward you. Thumb is magnetic field. And what will be the direction of current? Anti-clockwise, same thing. Correct. Based on the current, you can also tell the north pole and south pole. Because if it is anti-clockwise, then it will be north pole of the magnetic field. Correct? Barinder, if magnetic field is inside, thumb is away from you, your right hand thumb is away from your eyes, what will be the direction of the magnetic field? If current direction is inward, like away from your eyes, what will be the direction of magnetic field? This is current direction inward. What will be the direction of magnetic field? Barinder, clockwise. Clockwise. Observe, your thumb is going away from your eyes, right hand thumb, and your fingers are showing the magnetic field.
Right,
It
can't
is going
understand.
clockwise. Lift your right hand. Put your direction of your thumb away from you, away from your eyes. What will be the direction of the finger, clockwise or anti-clockwise? Pratigya. Pratigya, am I audible?
हाँ sir.
Wait then. Give me 2 minutes. Turn on video. Am I visible, guys?
Yes, sir, you are.
So, see this. If your thumb is toward you, then direction of the magnetic field will be anti-clockwise. Right? Anti, rotate like this. But if your thumb is away from you, then direction of your finger is clockwise. May I take you understood? Is there anybody have doubt? If your magnetic field is like this, direction of current will be anti-clockwise. If direction of the current is this, will be clockwise. Direction of magnetic field and current can change, but you have to always apply right hand, climbing right hand thumb rule. If thumb is current, then finger will be magnetic field. Finger current, then thumb will be magnetic field. Understood, guys?
Yes sir.
Yeah. But I think she's not. Okay. Move to the next point. Field at the axis of ring. We did same thing for the electric field also. Now it is about the magnetic field. You know, not I by 4 pi is the constant value. You have fixed current in your ring. I value is fixed, correct? You know upon 4 pi is fixed. If you take this dl small component of this dl, and if you integrate, did I write anywhere? I didn't. If you integrate the dl in this situation, what will be the integration value? Chandana,
Sir, can you repeat the question?
if you do integration of dl for a ring, what will be the value of integration? 2 pi r, correct? In this case, what is your distance r value? Actually, it is this r square plus x square under root. What will be of this? Because in formula you use r square. In this case, your r square value will be r square plus x square. That's all. That's why. Nu naught I upon 4 pi dl above and r square below. And r square value is this. Correct. And if you take sine theta component in this situation, because in your formula you have not I upon 4 pi dl value is 2 pi r square value is r square plus x square, and you know sine theta also you have in the formula. What will be sine theta value in this case? Perpendicular is r and hypotenuse is r square plus x square under root. Make sense? Now tell me, every time we are using Biot Savart law only, same formula, and you can solve anything using this.
सर आप एक बार फिर
Yes or no
बता
guys?
दो।
हाँ बिल्कुल। See, इसमें कोई डाउट है Brinder? In Biot Savart law, B
नो सर।
will only thing is here it will be dB because you have DL, small component. Okay. For ring, we have to calculate two, three things. Nu naught I by 4 pi is constant value. Okay. Nu naught I by 4 pi is constant value. For this ring, we want to calculate what is the DL value, what is R square value, and what will be the sin theta value. Make sense?
यस सर।
You ring like this and consider a small segment of this. This is and calculate the DL. What value? And ring is R. Circumference, it will be equal to total circumference, which is equal to 2 pi r. Any doubt? Brenda, any doubt?
नो सर।
No. If you don't have doubt, come to this point. When you are calculating magnetic field, you are calculating magnetic field P. You are calculating magnetic field at P from A point. So you will consider distance of AP in your radius. Example, if you are calculating R square value, now here R value is equal to AP because you are calculating magnetic field from A point. So with R value, A value, R square plus X square under root. Any doubt, Barinder?
No, sir.
What will be r square value then? Will be equal r square plus x square. Any doubt? Because in formula we had r square and value is r square. And thing, in formula we had sine theta also. In formula we had sine theta also. So how to calculate sine theta in this case? If this is the theta, if this is the theta, your sine theta is equal to perpendicular upon hypotenuse. Perpendicular is r and your hypotenuse is r square plus x square का whole under root. Yes or no? Barinder, I wrote something here. Ask your question. Barinder, any doubt? Anybody have doubt in this?
No doubts.
So tell me, guys, are you having only Biot Savart law application? How you had dipole moment or like any dipole here in same way we have magnetic moment. How dipole moment was charge into length. Same way, instead of charge, we have current in magnetic field. Instead of charge, we have current in magnetic field. And instead of length, we have area in magnetic. Area vector, sorry, not area, area vector. Area vector is perpendicular to the area. Same like if you remember, while we were doing electric flux, it was E vector dot ds vector, total integration. ds area vector, not area. Same A is area vector, not area. Remember, it is area vector. Magnetic dipole moments. Any doubt, guys? If you calculate magnetic field at the center of the ring, we already calculated. You have to just put dl value to pi r. As simple as that. You have to put dl value to pi r. Your job will be because that is what we have. Correct? Are applying this formula here. Then theta will be 90 in this situation. So, Tara, is magnetic field chapter difficult?
No, sir, not much.
No. Are you applying only Biot Savart law application as now a simple math?
Sir, I didn't do this chapter in detail.
But as of now, whatever we did in today's class, it is Biot Savart law and application of math.
Yeah, sir.
Right? Okay. Everybody, do you agree that this is purely Biot Savart law application?
Yes, sir, mostly.
Okay. ठीक है. At axis, you know your magnetic field. At the axis, you know at the center of the ring. You can calculate ratio between axis and center. ठीक है. Okay. And this is at the center, your value is high. Mu naught 4 pi I by r square and 4 pi r. Remember, when you calculate at any given axis, your x value is not 0, but at the center x value will become 0. Put x value, you will get center value. If you put x value here, what will happen? Everything will be 0. Your axis will become center. Make sense, guys? Yes or no? Okay, and if you don't understand, completely ignore it, because I have never seen this question. It was just correlation between the axis and center. If you can't correlate, just leave it without understanding anything. This circular arc is extremely important because here one thing is purely your uh, math. Like, Chandana, are you there? Chandana, how many of you are there? Chandana, can't you hear me? I think we have network issue. Anvita, can you hear me?
Yes, sir.
Okay. So tell me, what is the theta value in basic mathematics? Arc by radius. This is radius. This is arc. Correct.
Hmm.
What
Yes.
what will be your arc value? Theta into r.
Yeah.
Correct.
Hmm.
And if you take dl integration in this situation, what will be the integration of dl? Total length,
Yeah.
and total length is arc. So when we were doing uh, integration of your dl, it will be equal to arc, and arc is equal to r theta. We wrote the same stuff here. Then don't solve it completely. Just keep it like this only. I didn't solve it further in the active. Just I wrote the value of dl, r square, and sine theta. Same here, when I was calculating at the center, I wrote a dl integration, not further calculation. When I'm doing for the circular, I am just writing dl value as r theta, nothing. Make sense, guys? Any doubt?
No, sir.
Example in this case, if you see in second wire, angle is 180 degree. So what will be the magnetic field in this case? Instead of dl, you will have r pi. Done. Because your theta value will be 180 degree. What will happen in first case and third case? Angle with the center is 0. Correct? If angle with the center is 0, it means your theta will be 0. If your theta is 0, then your r theta will be 0, hmm, which will also equal to dl. Which means whole magnetic field will be 0. And you have seen this kind of question. When theta is 0, just imagine sine 0 value is 0, your magnetic field will be, because your magnetic field directly depend upon the sine theta angle. If your theta is 0, then your magnetic field will be 0. That's why in first and third case, your magnetic field will be 0. Here magnetic field is 0. Here field 0. Why? Theta is 0. Understood, guys? Make sense?
Yes, sir.
Then, so your application of Biot Savart law is done. It's like electric field is done. How in the same way magnetic field is done. There is no limit. We'll solve question. We'll get. I'll tell you further ki how we can solve different kind of question. But this is the basic understanding. Here, what you have to do only two things: Biot law and mathematical calculation. Ki how to do integration of DL. If you know what is the integration of DL in Biot Savart law, many calculation part is done. Anvita, how is it going?
Good, sir.
Pratigya, how is it going?
Yeah.
अच्छी देर ठीक है परिंदर
Good, sir.
चंदना is not there. Jordan,
So it's a little fast.
little bit fast,
Yeah, I find it a little fast, sir.
but you understood everything.
I'm understanding, but notes is little bit
Okay,
lag
I
behind.
will, I will. Sarah,
Good, sir.
so as Jordan, because it is very fast. So let me do summary what we did so far. So we are doing magnetic field, and in this magnetic field and Biot Savart law, it says that your if you take for small segment, example, this is one road, and this is the small segment of the road. For this, if you want to calculate magnetic field, it depend upon the current element I cross dl. It also depend upon the distance from you are measuring. Example, this is the point from I am measuring r. Okay, and you will have a constant nu naught upon 4 pi. If you apply the same logic, your final dB value is nu naught upon 4 pi I dl sin theta by r square. Any doubt in this, Jordan?
No, sir.
If there is no doubt, I will use it again. Uh, okay. So this is Biot. First, if you take for the road, for any kind of road is long. You take length segment. In this case, if you calculate your magnetic field, then your dB value will be equal to nu naught upon 4 pi I dl will be cancelled with one of the r value, and it will be sine alpha plus sine beta. Jordan, any doubt in this?
No, sir.
You have further application like special case of this. If you take infinite road, if you take infinite road, in that case, your alpha value will be 90 degree, your beta value will be 90 degree, your sine alpha plus sine beta value will be equal to 2. And because of that, your dB value will be equal to nu naught 2I by 4 pi r. Any doubt? Anybody?
No, sir.
Second possibility of the same thing. If you take finite rod or you take semi-finite rod, then your one angle will be 90 degree. We don't know which one, and one angle will be 0. Okay. In that case, your sine alpha, which is, let's take 90 sine 90 is equal to 1, plus sine beta value will be equal to 1. Okay. If you calculate dB, it will be equal to nu naught upon 4 pi, and I, this whole value is 1. Anybody have doubt in this?
No. So,
Okay. So this these two are the implementation of this formula, where you can derive this or you can derive that. Second, if you take at the axis of ring, axis of a ring, circular ring. So what will happen? Your dB value will be equal to nu naught upon 4 pi. I value is same. Your d value for a ring of radius r, 2 pi r. R square value will be r square plus x square, and your sine theta value will be perpendicular upon hypotenuse, r square plus x. But in this case, you have to make diagram. So I'll make diagram as well. If you have a ring like this, you have radius r like this. If you want to calculate at x distance this, and you are calculating from here a at this point p, this will be theta, and this value will be r square plus x square ka whole under root. Okay, that's why your sine theta value in this case will be equal to perpendicular is r and hypotenuse is r square plus x square ka whole under root. And your r square value will be equal to r square plus x square. Any doubt? Next, at the center of ring, if you take center of the ring, are you getting background noise, right?
no, sir.
Do you know the few minutes?
No, sir.
So, if you take center of ring, you will be not surprised. By using the same method, you can calculate the center of ring. Example, you, you can do directly from this, or you can do direct from this. In both situation, you can calculate center of ring. What will happen? Example: if you calculate directly from the Biot Savart law, dB value will be equal to nu naught upon 4 pi. Uh, Here theta will be is equal to 90 degree. I by r square, and your, if I am taking r, I will take this r, otherwise you will be confused. And your r value is equal to capital R. It will be r square, and integration of dl will be 2 pi r. Why I okay. You can use same thing also here. If you put x value 0, then what it will look like? Nu naught I 2 pi r by 4 pi r, r square plus x square. So x is 0, it will be r square into r, and if x you can eliminate, it will be r will be cancelled. Same method. So using this formula of axis of ring, you can calculate center of ring. Just put x value 0. Understood? Understood, guys? Any other
Yes, sir.
thing? Any other application? Yeah, at the circular, uh, in case of arc, if you take any arc, in case of arc, what will you do? If you calculate integration of dv, it will be equal to nu naught upon 4 pi I. Yes, sir. You, and like, you are not able to open this previous link. You are not able to open the previous link. Okay. So in of arc by r square, what will be your delta L value? R theta. Here, your delta L value will be equal to r theta in case of arc. Example, you have a circular arc. This is theta. Here, this value is r, and you can calculate what is your arc. And your Biot Savart law and its application is done. Jordan, how is this now? Is it too fast, or you understood every single thing?
It's better, sir. I've understood it.
Did I miss anything important? Current,
I don't think so.
yeah, Biot Savart law, field at axis, center, arc, ampere circuital law. Okay. So you can compare this law with your Gauss law. In Gauss law, you had E dot ds, E electric field ds area vector is equal to charge inside and epsilon naught. Almost same thing. Instead of E, you have B. Instead of for area, you have length for a given level. Epsilon, you have of charge you have for ampere law link structure. Structure, what I'm saying, it are very different. It can be for your infinite road. It can be different values delta L, you, because in Biot Savart you have same thing will be equal to nu naught I. But current present inside the magnetic field. How charge was present inside the system, current should be present inside the magnetic field. Example, in this case, you have three different current along a surface. So will be V dot dl, I2 plus. But you look at the direction. I1 and I3 are same direction. I2 not same direction. How? It is going down, and I1 and I3 are going up. I1, I3 going up. I2 is going down. That's why it is given in negative. Any doubt, guys? Simple addition, but you have to consider the this. You have to consider the direction of the current. Got it? Hollow cylinder. Example, if you take hollow cylinder and radius is more than the, sorry, m- your P point is more than the radius. No real value to note. The sur- surface magnetic field will be zero. Why? Because you don't come same in the shell or in any charge. In spherical shell like this, spherical shell, you will see your charge will be zero. Same here inside the cell is inside correct? Because current side is zero. And whenever you miss anything, always ask me. I was not able to get the topic, or like I missed the topic. Okay, so you can ask whenever you leave the meeting. Like you don't leave, there is some issue, network issue or anything. You can ask again, sir. I missed this topic. Can you please explain this again? Okay,
Missed
so
most
you
of
should
the.
not miss anything. Chandra, you missed most of the topic.
Yes, sir. I was there only for the Biot Savart law. After that, I can't hear you.
Okay, so next time, whenever you get back to the meeting properly, ask, "Okay, sir, I missed this topic. Can you quickly revise?" But I think I did revision in the end, this part. Were you there for this section?
No, sir.
Okay, so in the end, I will do revision for you. Come quick. Sarah is she is joining, so we can solenoid, toroid, cylinder. Yeah. Magnetic inside hollow cylinder is zero. But if you take solid cylinder, you know nu naught upon 4 pi, this nu naught upon 4 pi I r square common. What will be your DL value? 2 pi r. Remember, in this case, magnetic field actually depend upon the r value. And from two people are anything, how? Do I need to update the Jordan, I can see the update in this case.
So
How I can see update in this case? How I can update this?
you can't update it right now because you're using it, the app. If you have to update it, you have to like end the meeting and close the app and then update it.
Okay. So what you are doing in solid cylinder? Same using Biot Savart law. How? Because in Biot Savart law, your internal length will be 2 pi r. Example, you take solid cylinder. I will draw solid cylinder. Okay, the solid cylinder. And because it is solid, so it is completely filled, not like the hollow cylinder. Hmm. Okay, this is completely filled. Now, example, this is the center point, and you want to calculate your magnetic field at this R, at this point P from the center. So what will you do? You will redraw a cylinder like this, and only for the small cylinder you want to calculate your magnetic field. You know, in this case, your R value is lesser than the actual radius. Let's take this is capital R. So in that case, your magnetic field directly depend upon R. You increase R value, your magnetic field also increases. Exactly same way how in case of electric field, solid cylinder, electric field also increase. Understood? Guys? Electric field also increase in case of solid sphere. And and the try and
So your voice is breaking.
my voice is breaking a
Maybe
lot.
only for me, I'm not sure.
Is it for everyone like my voice is breaking?
Yes, sir.
Because I'm using mobile network. Just give me a minute. I'll make sure I do some adjustment. Solenoid. Jordan, what is solenoid?
So
Yes, Parthika.
क्लास कितने टाइम लेंगे?
Solenoid, toroid, charge in magnetic field, force, Lorentz force, torque. I have to take one more class, guys. I will finish only these two topics, solenoid and toroid. And then 15-minute questions, so maximum half an hour. Okay. Yes, Jordan.
So solenoid is basically a type of electromagnet formed by winding of a metal wire around the uh, basically around the body.
Correct. So when example you have a road and then around this road you uh, put metal wire. This structure, metal wire structure is known as solenoid. The important feature of this usually length is very big and radius is very small. I will show you solenoid. solenoid coil. So around the material you have coiled wire, so that is solenoid. Solenoid coiled wire. So what happen? You usually take small radius and very big length. You apply ampere circuital law B dot dl is equal to, you know, dot product is cos theta, correct? So total length of the rod is, let's take L. What will be equal to the current? Current will be Ni, number of turns, correct? So what is happen? This small n is number of turns per unit length. Small n is number of turn per unit length. If you consider this, then capital N number of turns will be equal to N into L, because total current will be equal to Ni. Total current will be equal to Ni. This, okay, and capital N is equal to small n L. L to L will be cancelled out. What will be the B value? No, not Ni. No, not Ni. Remember, small n is the number of turn per unit length, and capital N is number of turns. So both are different from each other. This happen at the center. Remember, if magnetic field is present outside this solenoid, magnetic field will be zero. If magnetic field is present perpendicular to the solenoid, it will be zero. Why? Because cos 90 value will be zero. Because cos 90 value will be zero. Reason here we have cos. Okay. Done. At the end point, you are taking one side only, not both sides. So one angle will be zero, another angle will be 90. You know, cos 90 value is 0 and cos 0 value is equal to 1. That's why whatever was your value at the center, half of the value will be present at the end. Got it? Reason? This. This is the real formula of the magnetic field. 1 by 2 mu naught n I cos theta 1 plus cos theta 2. In case of solenoid normal at the center, what will happen? These theta will be like 0. So cos 0 value is equal to 1 plus 1. Then at the center, this will be 1, this will be 1. And it will become like this. But at the end, one angle will be cos 90 will be 0 and another will be the 90 degree. So one theta is 0, another theta is 90. That's why here 1 by 2. So this is a real formula of magnetic field for the solenoid. This is the real formula of magnetic field for the solenoid. Whether you take at the center first situation or at the end second situation is the application of the same formula given in the end, this part. Okay, application of the same formula. How? How is that possible? Ki this is the main formula, because you are putting different angle in this situation. You are putting different angle in this situation, and then you calculate at the center and at the end. In toroid, exactly same thing, but in L value will be equal to 2 pi r. Why? Integration. Length is equal to 2 pi r circumference, but formula will be exactly same. If you take average radius in this case, how to take? Inner radius is A, outer radius is B. What will be the average? A plus B. Okay, and that that is more than enough for this class. I will solve question quickly, go through the whole content and ask your doubts. Till then, I will search your questions. I will wait 10 minutes. So how we did the Biot Savart law? We can do ampere circuital law. This ampere circuital law says that if you want to calculate magnetic field using the current, there are two methods. Both method will give the same value, whether it is Biot Savart law or ampere circuital law. We say that magnetic field associated with a given length, total integration will be equal to nu naught I net inside. Okay, it is comparable with your Gauss law E. Here E dot ds is equal to charge inside by epsilon naught Gauss law. It is almost like that. Okay, ampere circuital law. You can use this for the hollow cylinder. Sorry. Okay, so if you calculate for hollow cylinder, you know what will be the value of the magnetic field in this case. And in case of solid cylinder, what will be the value? Most important in case of hollow cylinder, your current inside is zero. That's why magnetic field inside the cylinder will be zero. But if you take solid cylinder, you can use this method nu naught upon 4 pi. Then this will be I by r square, and your length will be 2 pi r, small r. So it means magnetic field inside in case of solid sphere depend upon the radius, maximum at the surface. Then if you take solenoid, you will use same B dot dl integration will be equal to nu naught I. Remember, if you want to calculate total net current for the number of coil, it will be total number of coil and current in each coil. Okay, and small n is the number of turns, which is total number of coil per unit length. So your n value will be equal to n l I. Battery. So B मेरा तो रह गया. हाँ बुआ. BL is equal to nu naught. हाँ बुआ. बता 2-8 का होगा शायद. एक बार मैं पूछ के बताऊं. 2-8. 8-2 या 2-8 होएगा रह के. ठीक है. सारा सामान मिल गया. हेलो. हाँ. है काम में. ठीक है, मैं पूछ के बताऊं 5 मिनट में. ठीक. हाँ, so solenoid, this is the value guys, nu naught and I. This is at the center. At the end, it will be half nu naught and I by 2. This is at the end. So, what is the common formula for both? Your magnetic field will be 1 by 2 nu naught and I cos theta 1 plus cos theta 2. Okay, any doubt? This is the formula for solenoid. If you take at the center, what will happen? Here both the angle will be 0. Okay, at center theta 1 and theta 2 will be equal to 0. And at the end, one angle will be 90 degree, another angle will be 0. Then guys, ask me your doubt. Any doubt?
No, no, sir.
No, sir.
No, sir.
So we are already covered with a lot of question. Let me go through the question and show you. Mm, Magnetic field. Why I am not able to get magnetic field question? Check again. I don't have questions. I have to check PDF. There must be question. I still remember we did questions from this notification. You guys keep on revising your chapter because we are solving questions. बुआ हेलो। Guys, done? Any question?
Sir, can you explain the magnetic field at center of the ring?
At center of ring.
Yes.
1 minute. Tanma, you asked magnetic field at the center of ring. Correct?
What?
You asked magnetic field at the center of ring.
Yes, sir.
Huh. So you know, according to Biot Savart law,
Not this,
the,
sir. Not this one.
no, at the center of ring, na.
Sir, I have doubt in how magnetic field at axis is equals to center divided by r square plus h square.
See, this part is you don't focus much on this because you will be confused. If you are probably asking about this, right? This.
Yes.
So what is happening here? Example, if you take x value 0, okay, so the whole denominator will be 0. Yes or no? If x value is 0, whole denominator will be 0. No, it will be
No, sir.
r square divided by r square ka whole 3 by 2. So this it will be equal to 1. So can we say कि magnetic field at axis will be equal to magnetic field at the center if x value is 0. But if you take at any other place, then this is the thing. How we can get this? For this, you should know what happened in case of ring and what happened in case of axis. Okay. Example. Uh, where was this given? Yeah. Huh. So, example, if you take magnetic field for the ring, it will be equal to nu naught upon 4 pi I by r square and 2 pi r. Any doubt? For ring, dl value
No,
will be
sir.
equal to integration will be equal to 2 pi r. For the axis at any point, it will be equal to nu naught upon 4 pi I by r square plus x square. dl value again here it will be 2 pi r and sine theta value will be equal to r by r square plus x square whole 3 by 2. Any doubt?
No, sir.
If you take ratio b axis upon b ring, so what will happen? I will I will take this slightly below. Huh. So if you divide this value with magnetic field of the ring, which was nu naught upon 4 pi into I 2 pi r upon r square. This was the value, correct?
Yes, sir.
In this situation, this cancel with this cancel with this. In numerator, you have r by r square plus x square, the whole root 3 by 2. Because this is 1, this is 1 by 2, correct? So 1 by 2, it will be equal to this. Any doubt?
No, sir.
Divide by 1 by R square. Correct. What will be the value? R by R square plus X square का whole 3 by 2. And here it will be denominator of denominator will be numerator. Make sense?
Yes, sir.
Done. That's why we wrote here B at axis. B ring will be the multiplied form divide by R square plus X square whole 3 by 2 divide by R cube. Make sense?
Yes, sir, understand.
Even I didn't teach them because I told them ki you can ignore, but because you asked again, so I thought ki just take axis formula, take ring formula, take their ratio, you will get answer. Any other doubt, guys? Anybody? If you don't have any doubt, we can solve this topic in 2022. Jordan, 42 question. Biot Savart law gives us expression of the magnetic field strength of an infinite semi current element ideal of a current carrying conductor only. Is this correct?
Sir, he was not there.
Shara,
No, sir.
is this correct? 42 statement 1.
No, sir.
Answer is it is correct. Why?
So, but current. Oh, yeah, current, correct.
In Biot Savart law, it tell us about the magnetic field strength or magnetic field, right? For
Yes.
ideal element, whenever only there is current. If there is no current, then no magnetic field. So this is correct. Pratigya, second, Biot Savart law is analogous to the Coulomb inverse square law of the change of Q with the former.
Yes,
Former
sir.
means Biot
Correct,
Savart
sir.
law is related to scalar vector and ideal. Later, Coulomb's law is produced with the vector source Q. Correct, right?
Yes.
No, no. Why? Because ideal is the vector form and Q is scalar source. Q is scalar quantity, no? But ideal is a vector quantity. Make sense? Pratik, any doubt?
No,
Barinder, 43. Barinder, 43.
Sir, option D.
Yes. Because you know in vector nu naught upon 4 pi I dl. If you take r cap, then it will be r square. But you know r cap is equal to r vector divided by r magnitude. Correct? So that's why you will multiply by r vector divided by r magnitude. That's why this. Understood? Any doubt? Hello. Sanjay. Hello. Good. बुआ बात करो हवा 1 मिनट। हाँ बुआ ले लिया के सामान। हाँ एक बार बात करिए तन्नू गुला, एक बार करियो तन्नू गुला बात।
सुना ए तन्नू गला बात कर ले फोन में यो फोन का फोन ले रहा है वो बोल लगी।
Sorry, sir, this is a network issue.
हेलो गाइस, am I audible?
Yes, sir.
हेलो संजना, 44th क्वेश्चन। चंदना 44th।
Yes, sir. So 4.4
For
millitest.
one coil, it it is B is equal to nu naught upon 4 pi I by R square into 2 pi R for one coil. If you have n number of coil, then your magnetic field will be nu naught upon 4 pi I R square n into 2 pi R. Understood? So this R will be cancelled, 2 pi this will be cancelled, it will be equal to nu naught n I by 2R. Yes, Chandana. Chandana.
Sir, I got 4.4 millitesla.
4.4.
Option C.
By 2 R. What is the R value? 10 centimeters. So 1 by 10 and number of turn is 100. So 2 7. If you write this 22 by 7, 7 7 will be cancelled. 88. Hmm? Wait, I will explain it here. 4 n number of turns. Your magnetic field at the center will be nu naught upon 4 pi into I by R square and multiply by 2 pi R. Okay. Or this is also equal to nu naught I. This 1 R cancel. 2 pi will be equal to this 2. Right? So formula for the ring will be nu naught Ni by 2R. Correct? So for a number of turns. What is the value given? Guys, tell me. Nu naught is equal to 4 pi into 10 raised to power minus 7. Number of turn is 100. Then what is the current value?
7 ampere, sir.
7 ampere divided by 2R. What is the R value? 0.1 meter. So 1 by 10. Okay. 2 to the 4. Correct. Pi instead of pi you can write 22 by 7. 7 7 cancel. Correct. So what will be B value? 44 into this is 10 raised to power minus 7. 110. 10 raised to power minus 4 Tesla. Understood, guys? And don't write small n, write capital N because you will confuse with number of turn per unit length. Any doubt? Understood?
So they have given in millitesla.
Millitesla. Then if it is millitesla, you have to convert this into 10 raised to power minus 3. Correct? So how to convert into minus 3? You will take 4.4 into 10 raised to power minus 3.
Yes.
Tesla. So 4.4 millitesla. Any doubt, guys?
No, sir.
So answer will be C. Okay. Next, we'll do this later. Do this 46th question. Jordan, magnetic field on the axis of a circular loop of radius this, current this, at a point 1 meter away from the center of the loop is given by. Jordan, are you there?
No, he isn't there, sir.
Okay, Sarah. So tell me. Nu naught upon 4 pi r square plus x square whole 3 by 2. This was 2 pi r into r, 2 pi r square. Correct? Same axis formula I wrote in compiled form. Actually, axis formula is nu naught upon 4 pi I by 2 pi r. R square will be r square plus x square, and sine theta will be r by r square plus x square whole 1 by 2. So I compiled this. Okay, nu naught I 2 pi r square and r square plus x square 3 by 2. So your nu naught by 4 pi value will be 10 raised to power minus 7. I current value under root 2, 2 pi r square. What is r value? Radius 100 centimeter means 1 divide by r square will be 1 plus 1, 2 cube and under root. So what is the 2 cube? 8. And then under root of 8, 2 root 2. Correct? So it will be equal to 2 root 2. 2 root 2 cancel. It will be pi into 10 raised to 1 minus 7. Tell me guys, was it difficult or direct formula based question? This, you know, upon 4 pi I 2 pi r this, and r and x value is 1 1, so it's easy if 1 1 value is given. Correct. So many question will be like this. Ampere circuital law. Anvita, question number 60. Ampere circuit,
1 second, sir.
Ampere circuital law for long straight wire of cross
Yeah.
section area, study current, variation of the magnetic field inside and outside the wire.
So 1 second. Yeah.
Hmm.
Not sure, sir. Is it second option or first? Second one, I think.
See, if you take in this case, what will be your road is like your cylinder, correct? Road will be like your cylinder, so inside will be definitely it increase with increase in the distance up to the boundary. After that it will decrease by this. How do we know? There are two methods using Biot Savart law. You know, magnetic field inside depend upon r, magnetic field outside depend upon 1 by r. See in our notes. When you are taking this solid cylinder is like wire. So here inside it depend upon r, outside it inversely depend upon the distance. See this inverse distance. This understood? Any doubt? Any doubt? Because it will be equal to outside mu naught I by 2 pi r. It means inversely depend upon the r. But understood, guys? Anita, any doubt?
No, sir.
Barinder, 61. Pratigya is also there, no? Shape of the magnetic field line due to infinite long straight current carrying conductor will be. Magnetic field line because of the long infinite straight conductor will be.
C.
C circle. Why? Because if you take any long wire like this, then around this you will have this circular surface. Circular. Correct. Next, Pratigya. Infinitely long straight wire. In this case, formula is equal to mu naught upon 4 pi 2 I by R. This is the formula. Current is this. An electron moving with speed this parallel to the conductor, perpendicular distance between the this is this at any instant. Calculate the magnitude of force experienced by the electron. You have to calculate only magnetic field by using this formula, because later we'll discuss force will be equal to QVB. You have charge, you can calculate velocity is given, magnetic field is given, you can calculate. Understood? Any doubt, guys? So formula for infinite rod is this, and this is written infinitely long straight conductor 2I by R, and we discussed this. I'll do in the end solenoid. Solenoid toroid. But how many of you are there? Anvita, Brinder, Chandana, Jordan, can you hear me? Jordan, Sarah, can you hear
Yes,
me?
the network's weird. It's not proper here.
Okay, then solve 74th question. This radius, this number of turns per mm, this current, what will be magnetic field strength? Hello, Azad. हाँ ना, फिर यू कल्याण थे नहीं तो ये बुआ ओड़े बिकी थी गामो में चले। हाँ हाँ नहीं नहीं, तो भी मैंने तो नहीं लगा कि मोटरसाइकिल पर तो तंग हो जाएगा, तो भी गाड़ी में ले। फिर तो वो रेडी लेके जाओगे अगर ज्यादा। ठीक है, ठीक है। तो मैं तेरे तरफ भेज रखा है कि भेज रहा है पेज? ठीक है, मैं एक बार चेक कर लिया, दोबारा नहीं मैं भेज दूँ। जरूर जरूर, ठीक है। सो व्हाट इज योर आंसर, जॉर्डन?
So option A.
Yes. Why? Because your new note value is 4 pi into 10 raised to power minus 7. N value in this case will be equal to 100 tons. 100 tons per millimeter cube, 10 raised to power minus 3. And current is 1. It will go up 10 raised to power 5 plus it will be minus 2. Done. Anvita, 75. This centimeter length having 100 tons and this current, what will be the magnetic field at the center? Remember, every time we are calculating at the center. Yes, Anvita.
So just a minute.
Mhm.
So
Got it?
we'll get B. No,
B.
no, sorry, 1 second. D, I'm getting D.
Yes. Understood? 4 pi into 10 raised to power minus 7. Your number of tons are 100 in 50 centimeter. If you convert centimeter into meter, 10 raised to power minus 2. And your current is 2.5 ampere, so 25 by 10. So 25 to the 50. This to the 2 pi. If you take this 1010 cancel, minus 2 will go up, it will become plus 2. So it 2 pi, it is plus 3. So 10 raised to power minus 4. Understood? So tell me, guys, is questions of this is really difficult? We are left with the torque value, galvanometer. Actually, you have a lot of questions from this. Galvanometer, torque, force between this. Half of the chapter is almost left. So 170 again. So all of you are okay to take class at 3 o'clock?
Yes, sir.
At 3 o'clock, we'll have chemistry today. Which chemistry? Solution.
Okay, sir.
And I'll finish solution today. Full solution I'll complete. Today is 15. How many chapters in the physics is left? Today, if I do physics, this chapter 1, 2, 3, 4. Oh my god.
So what time did you say the next class will be? The network's very
4
weak.
o'clock. 4, 4,
4
4.
o'clock. Okay,
Yes.
sir.
Okay, but you have to do 20, not 20, 20 will be too much. 15 question from this topic, moving charge and magnetism. From the topic what we did so far, not everything. Example, we did this part. Motion in the magnetic field we didn't do. First topic we didn't do. Magnetic force, no. Magnetic field done. Magnetic field on the axis of the circular current loop is done, the full topic. Ampere circuital law done. After ampere circuital law, solenoid is done. So between Between 42 to 76. You have almost 8 questions. No, 35 questions. Out of 35, you have to do 15 questions. Okay. And send before 3 o'clock. Okay. Send before 3 o'clock.